Welcome to the project demonstration of Tribrid power generation system along with GPS tracking and also automatic controlling of street lights based on LDR and IR sensor. So here Tribrid nothing but piezo plates which are mounted inside the shoes, and wind power generation from this wind turbine along with the dynamo, and solar power generation from this solar panel. So these three are generated and in that one coming to the solar and wind are connected to the battery section at this street light and use it to control the street lights whenever the darkness detected with the help of this LDR. At the same time, if the vehicle presents, then the brightness will be increased to 100%. If the vehicle was not present and during the night time, only 50% of brightness will be provided for the street lights. Coming to the piezo plates, we have mounted the piezo plates inside this shoe and that were connected in series in order to get the 5 volts maximum, which is sufficient to charge a battery. So here we have mounted the piezo plates inside that in series. So the output from these piezo plates is input to this 3.7 volts 2600 milliampere lithium polymer battery, lithium ion battery, and here we are going to recharge this battery with the help of piezo plates along with a charging section with B-type charger. So the main purpose of this shoe section is we can track the person, those who wore the shoe, with the help of GPS and IoT module ESP8266. So these two are interfaced to the microcontroller. From here the data will be streamed to the mobile phone through the IoT application. So here coming to the piezo shoe section, this is the main on-off switch. And coming to the street light section module, in this one the wind and solar is connected to this 12 volt 1 amp battery, which is rechargeable battery. So in order to charge this battery, we have provided the 3 sources irrespective of solar, wind is there, and also if none of them available, in order to charge a battery we have placed a transformer which will take 230 volts AC input and provide us the 12 volts AC output to the charging circuit. So on the charging circuit we have the bridge rectifier and diodes are connected in a manner of bridge rectifier to convert the AC to pulsating DC, and after that the capacitor will rectify that pulsating DC and to provide the pure DC voltage, and that is the input to the battery circuits. On the transformer and connect the transformer at S, remove that, and T, connect this. So now this battery is charging. So it will take 6 to 8 hours either from the solar panel or wind or transformer. So maximum 8 hours it will get in fully charged, and after that in final demonstration no need of the transformer, just go with the solar panel and the wind. So whenever the wind rotates, we can see the light on this charging circuit. And solar also, if you place this under the full sunlight, we can get the high brightness on this solar LED indication. And here is the main on-off switch to control the street lights, and when we on that, on this LCD display we can get the voltages of solar and wind. So initially welcome message will be displayed. So as of now low light is coming from the solar panel, that's why the solar panel voltage is 0.2 volts. And coming to the wind, so rotating it in anti-clockwise, we can see the wind voltage. Right, we place the most lighting on the solar panel, we are getting the voltage. Okay, so we can see the wind voltage also increases. And coming to this light street light section, so whenever the darkness detects, as we discussed, it will provide us the 50% brightness to the street light section. So 50% brightness was provided, and whenever any vehicle enters from this IR sensor, when it crosses that, then automatically brightness increases. After some time it will closes, means the brightness will come into the normal, and that brightness will be decided by this LDR sensor. During daytime, if vehicle enter also, it won't control the street lights. Right, coming to the shoe section, so in order to track the person live location from the mobile phone, so before on the kit, so now let us keep this off Now let's check with the shoe section. Right, now coming to the shoe section. First of all, we need to install the two applications. One is the Juice SSH, so this application available in the Play Store, and another is Network Analyzer application. From this Juice application, we can get the live location into the app, and Network Analyzer to get the IP address of our shoe. Go to hotspot settings, change the hotspot name to project 5730 without any space, without any capital letter, and password should be 123456789. AP band should be 2.4 gigahertz. After that, enable the hotspot, and now you can on the shoe section. So this is the main on off switch. Now you can see one device will be connected in your mobile phone, right? One device is connected. After seeing that, go to Network Analyzer application, options, LAN scan, do the scan, and you will get the ESpress. Copy that. Go to Juice SSH application. In that, manage connection. Add. First of all, type telnet and address. Copy and paste. Port number 8080. Three changes. Type telnet, address which we got from the Network Analyzer application, and a port 8080. Click on OK. Now you can connect to that. So we are getting live location directly. As of now, we are demonstrating the project under the indoor. So under the roof, there is no sky vision, means there is no satellite vision for this GPS antenna. That's why we are getting 00. If we place this execution under the sky view, then the GPS will get the satellite vision and it will provide the live location directly to this mobile application. Yeah, and here also we have provided the second half charger. So just we need to connect the B-type charger to this slot. Okay, now that the light will blinks when it is charging. So right now it's blinking. So here we have the indication of once the battery is fully charged, this light will stops blinking and it will continuously on. So that is the indication of battery is fully charged. After that you can disconnect here. Coming to the interfacing connections, at this section we have interface with GPS module at the microcontroller, pin number 1 and pin number 8 and 9 interface to the ESP8266 Wi-Fi module, and the battery is directly to the power supply section through this boost converter. And coming to this streetlight section, we have interface the LCD H PIC 16F72 microcontroller at B2 to B7, and next IR sensor interface at the A4, voltage sensor of wind at A2, A1 for the solar voltage sensor, and LDR at A0, and C2 for the street light brightness controlling through this transistor board. So this one LDR sensor, transistor board to control the brightness of these two street lights, which is operated of 12 volts. And next on this motherboard we can see the voltage regulator, which will take 12 volts DC inputs and provide us the 5 volts DC output, as the operating voltage of our all remaining electronic components is 5 volts only. And coming to this charging circuits, voltage sensor for the wind, charging circuit for the solar along with voltage sensor for that.